comment, the teacher who wants to research about their own practice and learn more about their own practice. And one of the characteristics that you need in order to do that is to be able to reflect, to be able to think about what happened yesterday or this morning during my
How can I do it better?
How can I do it better? Exactly. Are there any other characteristics you would add here to this list that you think helps make a supportive instructional environment? Anyone want to share? Please.
We talk a lot of every school having a mission and a vision, but I feel that they're just documents on the wall.
Yeah, they're not live.
But to actually have, an understanding of what is learning.
Mm-hmm.
Learning is the key, and so everyone has a common goal on, okay, what is our goal in terms of learning and instruction in the school, and to have a common understanding of that gives you a foundation to build on.
Is huge. So the way I often ask that question is I say, what is our purpose at this school? And if I ask 3 people and I get 3 different answers, I know I have a problem. Because I may have one person who feels that the purpose of schooling is to educate the whole child, to worry about the social, emotional, as well as the academic. I may ask another person who says, it's really just about getting a good score on the test. Well, those 2 attitudes are in conflict with each other. And so the person who worries about the social, emotional well-being of the child may have an argument with the one who's all about academics. And that's a problem. So I agree, being clear about your mission, your purpose, whatever. So one of the things we know is that as accountability increases, we need to keep in mind the psychological safety in a particular school. And this is a 2x2. And essentially, if I have a school that has low safety and low accountability, it's really apathetic. It's sort of like nobody cares what happens. If I increase the accountability but keep the safety low, people get really worried, like the question I took this morning, which was, when you come into the classroom, don't you feel nervous that the directors come to see you? Similarly, if I keep the accountability low and the safety is high, everybody's kind of laid back. There's no worry, no tension. And ideally, the high performance is here, where you have high accountability and high safety. And that's something that for school leaders, I think is really important to keep in mind. It is good to have high accountability, to hold teachers accountable, to hold students accountable, but through having a safe environment and a supportive environment. So how do we improve instruction? This is the forever question that everyone's interested in. The first thing that I think is really important is that practitioners, teachers, engage in face-to-face conversations about instruction, about the practice of teaching and learning. I think that interactions really occur socially, as opposed to academically reading in a book about what is good instructional practice. I think it's much more powerful if 2 teachers or 3 teachers or a teacher team or a grade level team comes together and actually tackles this question. I think the power comes from colleagues working together on a problem of practice. By a problem of practice, I might mean that for those of you who are math department chairs, and I forgive me for only giving math examples, but that's what I know. If you're in a math department and you give some sort of an assessment and you see that children are really weak in their understanding of rational numbers, of fractions, if you will, then that's a problem of practice. And you should take that to a group of teachers and say, the data show that our students are weak in understanding fractions. What are we going to do about it? And I feel that the power of that situation would really make a difference if you have colleagues working together. Obviously, this all happens in the world of trust. You don't have to do I have to put my shoes on? No, I don't want anybody to be embarrassed. So we need trust, and then finally we need an idea of continuous improvement, that everyone is going to get better, that we all can get better, and really be very good. So what process will do this? Well, one is, first of all, having a process. There are many different ways that you can improve instruction, but you need to have an agreed upon, understood pattern by which we're going to work on our own instruction. If it's just helter-skelter, one day you'll do this, another day someone will come and visit you, another day someone will look at data, then teachers don't really know where to put their energy. So number one is to have a process for improvement, which can be an observation protocol, a schedule for observations, teachers observing each other, and then time, that critical factor, which none of us have enough of to be able to reflect on what they do. So one is a process, and the second one is this thing I'm going to teach you about today, which is called instructional rounds. Instructional rounds is like they do in a medical school or in a hospital. A group of doctors come to your bedside and they confer, they talk, they look you over, they look over the patient, and one says, I think we need to do this, another one says, I think we need to do that. No one in the room is feeling awkward. All of the doctors realize this is a wonderful way to learn from each other. And so the instructional rounds asks 4 basic questions, very simple questions. The first question is, what are the children doing and saying? So if I step into one of your classrooms, I say to myself, what are your children doing and saying? Are they watching? Are they taking notes? Are they passively not engaged? What are the children saying and doing? The second one is, what is the teacher doing and saying? Is the teacher lecturing like I'm doing right now? Are the students responding? Where is the talk? The most critical question is, what is the task? What is the teacher asking the students to do? And this is where I want to really focus our observations today, so that you can get a sense that if you change the demand, the level of the task, your students will perform better. Because students do what we ask them to do. If you ask them to do very low-level tasks like, what's 8 times 6, or what's 9 times 4, that's memory. That's not thinking. If we continue to ask them these low-level kinds of questions, not demanding, that's what they'll be able to do on a test. And as soon as the test, whether it's a PISA test, whether it's an International Baccalaureate test, asks a higher level skill, the kids are helpless. They don't know what to do. So, this instructional task, as I say, is the most important one. But the test, the sort of pressure test, is what would the children be able to know, what would they know and be able to do if they did everything the teacher asked? So let me give you a concrete example, again, from mathematics. A lot of our mathematics, at least in the States, is teacher presents a new approach to factoring a quadratic equation. Up at the board, I do one. Next, I have all of us do ones together, right? So it's I do, you do. And then maybe I put 2 or 3 more on the board and ask you to do it. And then finally, I assign homework and the class is over. So when you think about that, at the end of the class, what the children will be able to do is to copy from the board try to see a pattern for how I did this. They won't necessarily understand how to factor a quadratic. So, focusing on the instructional core means, as I said, we take as a definition, the instructional core has 3 parts. The content that you're teaching, the students who are in front of you, and the pedagogical skill of the teacher. And these all relate. In fact, like interconnected. If I change the content, either up or down, it's going to change how the teacher teaches and what happens to the students. They're all related. If I change the student engagement, students aren't very interested. And the teacher has to change, the content has to change. So these three pieces work very closely together. And in the center is what we call the task, the actual task. That would be a good picture to take. Okay? Because that's what we're going to talk about. Everybody set? So, this is from my colleague Richard Elmore. It's called Instructional Rounds. It's not a very expensive paperback book where this is all described, but I'll tell you more than you need to know. So, all right. So, the tasks form your basic unit of instruction. They influence what the learners do by directing their attention to the kinds of problems that you want them to be able to do. They work in schools. Their work in schools is defined by these tasks, and it's what we ask of them. So it is a huge wedge or lever into changing student cognition. If we just look, it's so simple really. If we just look at the kind of questions, the kind of tasks that we set for students, it is in our control. Regardless of what curriculum you're teaching, regardless of what your supervisor says, what you ask students to do is totally under the control of you as professionals. It has to do, and I'm sure many of you have heard of Bloom's taxonomy, which is a hierarchical system of thinking skills. It looks something like this. It's been revised a few times. Again, the low level here is the remembering, memory, recall. Then we move to understanding. All right, now I can take my memory and I can use it in a new situation. Then I can apply it to a story or to an example. Then I can analyze whether that tool that I'm using, that particular knowledge, is the right one to be used now. I can evaluate it, and clearly at the top is creating a new understanding. So let me give you an example. Go back. I want to go back. Let me give you an example. And here, I don't want to put anyone whose first language is not English on the spot, but I noticed that you are, I think, an English speaker. Okay? Would you read the first line as fast as you can? Second. Third. Pretty easy, right? Okay. Do I have another English speaker? I don't want to, really challenge. You are. Okay. Here's the next one. Say the colors as fast as you can. Say the colors as fast as you can.
Red, green,
Colors.
green, yellow, red, blue. Green, blue, red, yellow, blue, red, green.
Now that was harder. It made your brain hurt.
Yes.
This is the difference between, let me go back to the first one. This is the colors as fast as you can. Red, blue, green, yellow, so forth. That's the colors as fast as you can. You're using in your head some memory of the word and the color. Now when I go to this next level, now I've sort of short-circuited things because I'm asking you to read the letters which read as red, but I want you to say the color, which is green. So it's a perfect example of phrasing. What I say to the students is it kind of makes your head hurt. This was much harder. And that's one way to understand cognitive demand. Okay? So it's a good example of that. Why was it harder than the first? Because on the second one, you were keyed one way, but it wasn't what you were being asked to do. So students in very good high schools are generally taught procedures, not to puzzle, not to think, not to take risks or to conjecture. The emphasis is getting the right answer. And these tasks are routinely low level. Let me give you an example. Can anyone explain to me why 1/2 divided by 2/3 equals 3/4? Explain why, please.
Because when we divide, we take the first,
It's the procedure.
the first thing, the same division, multiplication, and things.
Why?
Why? It's not the why.
I want to know.
When you want to divide, I want to explain it.
Yes.
Which again, the numbers are half.
1/2 divided, you can write it down if you want. 1/2 divided by 2/3 equals 3/4. I want someone to explain to me why the answer is 3/4. Go ahead, you started and then you can go next.
Maybe if I can put it in an example, if you have half a loaf of bread and you want to divide it between 100 people, you want to divide it between 2/3 of them, which is how much we each get, something like that. To put it in real number of people.
If we have half a loaf,
1/2.
yeah, and then we want to make it into three something like that.
Okay.
Maybe you can
Take it out.
2/3 of the unit is usually 1/2 the unit. 3/4 of the unit times.
Did you all hear that?
No.
Say it nice and loud.
2/3 of the unit fits into 1/2 the unit, 3/4 of that unit's size, or 3/4 of that unit's time.
He is right. But what do we teach? Flip and multiply. And no student that I've met really often can explain why that's so. Now you can do reciprocals, you can do dividing by 1, you can kind of turn yourself into a pretzel and do a description. The way I like to explain it, which I hope is socially acceptable, culturally acceptable here, is if you have 6 bottles of beer, or it could be soda. All right, 6 Coke bottles. What is 1/2 of 6 Coke bottles? 3. Now, what is 2/3 of 6 Coke bottles? 4. So, how much? I've got 3 in the original one. 1/2 is 3, and I've got 4 in the other ones. How many of the 4s are going to fit in those 3? Only 3 parts out of 4. Now you may think that's harder than knowing the procedure, but my point is to explore the why and ask students the why. If you don't ask the students why, they won't ever answer it. Absolutely. Well, plenty of research about this. There's a woman named Li Ma, M-A, is her last name, Chinese, and she studied the knowledge of Chinese elementary school teachers and American U.S. Elementary school teachers, and she found that the Americans completely had no idea why it worked. Why? Because they've never been asked. So it's cyclical. All right, so the other part of this idea of raising the cognitive demand is that we are caring people as teachers. We don't want you to be uncomfortable. We don't want you to struggle with an answer. So as soon as I give you a question and I see that you're having a hard time, I'm going to leap in and show you how to do it. And there's a delicate balance here, because if you struggle too much, you'll give up. But there's plenty of psychological research that shows if you push the sort of zone of proximal development, if some of you know this language, you will get more engagement by the students. All right, so we call it productive struggle, not worthless struggle. So often we suggest starting your classes with a problem, with a task that might be just a little too beyond where they are, and let them work on it. And tell them, this is a little harder than you are accustomed to. It doesn't have to be a secret, but you're going to teach in a little different way. And then putting the students together to struggle together. And this is the power of students working in groups, because all the students have different approaches, and they start to see, oh, you know, I see what you're doing there. Well, that helped me, or it didn't help me. Whereas when we teach the way I'm doing right now, you're only hearing me tell you one way to think about this. So you reward not for the correct answer, but for rather the reasoning, the thinking. And the struggle must be modeled. Otherwise, students will give up. They'll say, this is too hard, I can't do it, I'm helpless. So keep productive struggle in mind, and that's another way to raise your level. So it's important to do with the curriculum, but more importantly, it's how the classes are taught. So how do you change the instructional focus? You focus on the tasks. All right. So I wanted to show you, these are the 4 questions you need to ask. No other questions when you go into a classroom. What are the students doing? What is the teacher doing? What is the task? And then finally, if the students did everything that the teacher asked them to do, what would they walk out the door knowing and needing to do? So look at this task. This is a task from our state assessment. Would you characterize this as low level, medium level, or high level? Low? Tell me why low. There is an answer there. I may not know exactly which one it is, but I might be a very clever test taker who's been taught to eliminate ones that don't work. Okay? It causes some memory. I need to remember the distributive law. Okay? But beyond that, it's not very good. Would you agree? It's more applying a rule. All right? Here's another one. I want you to turn to someone sitting next to you and think about what your answer would be to this. And how challenging do you have it? The graph shows the speed of a racing car. Here, this is the speed and the distance along the track. So it's going very fast here, then it slows down, then it speeds up, it goes steady, then it slows down more, speeds up, steady, slows down. Which of these pictures over here is the picture of the track, that the car travels? And this is where it starts, the circle is where it starts, and the arrow is the direction that it goes. Okay? Which of the ones do you think? You can talk to each other. You don't have to suffer in silence. Talk to each other. Okay. This one over here. This one. Okay. I have heard every possible answer. Which one do you think it is? This one.
No, the next one.
This one? It's flat the whole time. So it's flat. We don't have to worry about hills and whatever. All right, let's try to eliminate a few here. Let's take this bottom one here. Right away, as soon as I start, I've got to do a turn. So I'm going to have to slow down, right? Because I can't go as fast when I'm driving through a turn. So, and then I get down here, it's a very sharp turn, and then I can speed up. I get here, but not very long there, before I go down again here. Does anyone think this is still the right one? No. All right. It is not. I'll tell you that right now. How about this one up here? I start here, I go up, and then I make a turn, and I come down pretty, it's pretty sharp, but not as sharp as that. Pretty sharp, then I go back up, and then I'm fast. This is not as steep as that one. Come around, this one is really sharp, so this is going to be different from this one and from this one. Is it different enough? What do you think?
Could you count turns?
How do you count turns?
Well, they slow down to turns.
Yeah.
And so the graph you just pointed at, there's one right off the bat. And
Yep.
then your cursor there, your light at 2. The next is 3, the next is 4, yeah, 5, 6, 7, 8, 9 turns. There's only 3 slowdowns. So there can only be 3 turns in the graph.
Everybody with him on that one?
Yeah.
All right, keep going. We know we want 3 turns on the graph. Well, can't be the cone down here, the bottom one. Can't be that one. How do we distinguish between these 3? Go ahead, you're on to a roll.
My distinguished math chair and I agree that it's the one with that one there.
Why?
Well, there's a turn right away.
Okay, turn right away.
There's a little bit of straightaway, and then there's a deeper turn because you're gonna have to, the car taking the track is gonna have to turn about 270 degrees, like come all the way around to the right. So that you slow way down. And then another straightaway about the same length as the first one, roughly. And then another turn about the depth of the first one.
Yep.
And then not much of a drive before you finish the line. So we kind of, for a moment, debated
Over here.
between that one and the one all the way to the right.
Yeah.
But the straightaway at the end of the right moves out. So
Okay, so right away you have to slow down, then you go straight. Then you've got a pretty steep curve, but a very modest curve.
yeah,
So,
and it's not really as much as the first one.
okay. You got it right. Great example of a cognitive demand. This is an item on the PISA. You know about the PISA exam? For 15-year-olds. Okay? It's a good one, right? So, back to Massachusetts, back to my home state in science. This is my tip to you in science. What do I have to know to be able to answer this question over here? It's just memory, isn't it? Recall. Recall. And help me, science people. What is solid? Is it number 4? Yeah. I need to have learned that somewhere. There's no way I could know that or figure that out from this question. Okay? Over here, how would I know the answer to that if I had not memorized what a chemical compound? What stays the same? Does anyone know? I don't. Atom? Is it atom or molecule? Molecule? I don't know. I can't help you with that. I don't care. I will leave that one for you to think about.
You see, right?
I don't know. Molecule? All right. I defer to you. My point in these two is it's pretty much a memory. Nothing in the problem allows me to work the problem. It's a guess. Either I remember it or I don't. And the reason that we started, I'm not saying that memory does not play a role. In other words, memory does play a role in math and science. But there's more to it besides that. And the reason that we want to get more to it is that if you forget, if your memory fails you, like mine is failing me a lot these days, all right, because I'm getting old, I don't have any way to figure it out. It's either I know it or I don't. And so this is why part of the situation is. I was going to show you a video here, which I think I will skip now, but these are the international math and science videos. I show you a dreadful example of a math teacher in the United States teaching. She takes about 20 minutes to get the class started. And now much of the work that we do now is we have, as students come in the door, there is a do now exercise by the door. They're trained. This takes you 2 minutes to train them to do this. Whenever you enter my classroom door, you pick up this piece of paper, you move to your seat, and you work on the problem. While I'm taking attendance, handing out a book, giving you an extra piece of paper. No minute is wasted in terms of students engaging in the content. All right, cognitive demand. So I've talked a lot about cognitive demand with you now. That's kind of like how hard it is. But this is new work. This is my own work I'm about to show you. Is that I think a task can be characterized both by cognitive demand. Is it memory? Is it analysis and evaluation? But I think it also can be evaluated on a continuum of how many different pieces of knowledge do I need to bring to be able to solve this question. So sometimes you see in books they talk about one-step and two-step problems. So along that continuum on the content side might be five-step problems. Well, that's really hard, but it could be real easy. Okay, so let me show you this example. Tasks can be from high to low, and tasks can be high on cognitive demand. I think I've talked about all of these. But the complexity of the content is the following. Draw yourself on a piece of paper this picture. Again, low, 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 high, high, low, and high, high. And when you look at a task that you give a child, I want you to think not only about the cognitive demand, which is it low-level memory, application, analysis, and so forth, but how many different pieces of math do I need to bring together in order to be able to do this? Well, think about these four tasks, and take a moment with your friend next to you to decide which quadrant you would put these tasks into. Okay? Let me just say that again. Your task right now is to draw this blank quadrant on your paper. And now look at these tasks. Each of those bullet points is a task. And decide which one goes in the bottom left, where it's low complex of content and low cognitive demand, so forth and so on. You understand? Okay, let me show that to you. You didn't know you were going to have to work, did you? Where would you put these? Too hard? I'm just trying to help you understand how you can examine the task for its level. Let me ask a simpler question. Which of those 4 questions do you think really only relies on memory? The last one. This one?
The one before, the one before.
What numeral is in the tens place? I kind of think this one is very low level cognitive demand. I need to remember what is the tens, and then I need to know what the word numeral is. So I would suggest this goes on the bottom left as low demand, low complexity. Okay? Next. What do you think, what you know? Well, tell me, what do you think is the hardest one there? The demonstrate. It says, show me you know you've got them all. Not just you can find one, but it's almost like doing a proof and saying, oh, I've got all of them. So I would argue that this one, right here, is the hardest. It's the highest in cognitive demand, and it's the highest in the complexity that I need to bring to it. I need to bring through an idea of what is demonstrate, essentially what is a proof. Also the notion of all. That gets pretty hard.
It even connects, depending on what class you're doing it, I'm trying to contextually.
Yeah.
If you're doing this in a grade 7 or 8 math class, you're grabbing ideas of proof, which you probably don't
Haven't covered yet.
You haven't really explicitly taught that idea until maybe grade 9 or 10, and so it's really cognitively demanding.
Yep. And then the other 2 we could argue about, but here is how I filled in the graph. The easiest one is what numerals in the tens place. I just have to remember ones, tens, hundred, thousands. The next one is find as many numbers as you can that has the same number of tens. How many tens does 4,123 have? Anyone else? How many tens would I find in this number? Well, you divide it by 10, 1. But quickly, you should know it's 412. Okay? So what would be another number that would have 412 tens in it? Great, 4,124, 4,125. Okay, now that was a little harder because I had to sort of, first of all, know how many tens were in there, not just the numeral, but overall. And then now running up the way. Okay, so you don't have to use this as you think about your tasks, but I just want to impress upon you that in one class, you could have some students working up here in the high, at least thinking about it. Some students working down here in the low. Every student is thinking about 4,123. Now, people get together. It's a way to dig into this. So I have for you another set of tasks that I would like you to look at just very quickly and think about which is really, really hard, high, which is not so hard, low, and in between. So. They're on the back and on the front. I guess they're all on the front. Thank you. So which looks, just pushing you along here, I know I have to give you my question, which looks to be like memory. The first one, right? Y equals mx plus b. Know what m is, know what b is, find it. So let's call task 1 low, low. That leaves us 3 other ones to figure out, and we can argue. There's nothing right or wrong about this. But what do you think might be the next challenging task that, well, let's take the hardest one so we can fill in the others. What's the high? You think the second one's the high? And why is the second one high? Explain is one thing that makes it harder. Predict is another thing. You all, because you're experienced math teachers, are kind of into this and say, well, wait, now let me figure it, let me look here. You're starting to calculate, you're starting to think. I've raised the demand. In some ways, you might call it more interesting problem. But I think task number 2 is a high. Now the other 2, we could argue about. I think task 4, probably if I can graph, then, we could argue. Which, yeah, high first, low second. We can argue. The most important ones are the 2 corners. Yeah, I think number 4 is low on cognitive demand, but higher because I have to be able to graph it and then I have to be able to label those points. You can have a nice time talking about this while you drive home. Okay. All right. So my point here is that by having tasks like this, it provides an opportunity, and if we weren't in such a shortened time frame, we would be talking about these things. It provides grist content for teachers to have legitimate conversations about content and about teaching. So, this is a tool to focus on the important aspects of instruction. And what we're trying to do is for you to think about, first of all, the tasks as they appear in the curriculum materials that someone gave you, whether it's IB, whether it's state, whether it's whoever. And then they're set up by teachers, but then this is the really critical part right here. As they're enacted by the students, really is what drives the student learning. So you can start with a task as it appears in your textbooks, but I want you to think about how you set it up as a teacher to ask more probing questions. Why is that so? How many other examples can you find? Forget for the moment, and I know this is hard for all of us as math teachers, forget getting the answer. The more conversation you can foster among students, student to student, student to teacher, teacher to teacher, the more understanding you will develop. So I want to hear 3 takeaways, 3 things that you learned today, 2 things that you'll do as a result, and 1 person who will hold you accountable. So who wants to say, since we've got a group of 3 here and you're going to be working together, what are some things you learned today? Yeah. Everyone's voice. What did you learn? 3 things you learned today. I think it's
Help students to think.
Okay. All right.
And make them work together with the teacher.
Okay.
And study on the health accounting.
All right.
I don't think it's working.
All right. Someone else. What did you learn?
Well, when you set up a task, which is a pen and paper kind of test one, ask yourself for the question, what is the cognitive demand? and how complex is the task, and maybe have a balance, because I think
Absolutely.
too much high
Absolutely.
will cause a.
Thank you. Sorry, I did not mention that. Yeah, you spend all your time up there in the top right-hand corner, the kids will give up. It's a balance, making sure, but make sure you touch every quadrant in your work. That's a great one. So 2 things you'll promise to do differently as today. What's one thing you might do? What might you do differently? You can't sit in here for an hour and not be held accountable. What are you going to do differently?
Maybe I'm going to change my post-efficiency chart.
Okay. 4 questions. What are the students doing? What's the teacher doing? What is the task? And then ask yourself, if the students did everything that the teacher asked, what would they be able to do? Okay. Another thing you will do differently.
I would do now is I go back and work with my teacher on
Great. Right. And make sure that at least they get a couple of questions that push that up. Good. What would you do?
I'd like to focus on the culture aspect as opposed to the technical part.
Very good. Why are we, one thing I ask my Harvard College students all the time is, why do we have schools? If we had another hour, we could all discuss that, because I can guarantee you we do not all have the same answer. Really. And so if you're an administrator, having a conversation with your math teachers or your science teachers or your entire 4th grade, why do we have schools, is very enlightening. Very enlightening and necessary. So, all right, thank you very much. It's 5 o'clock. Enjoy yourselves. And if you, I want to just say, if you would like to ask probably Mary Tadros, who's with the Queen Rania Teacher Academy, she has this PowerPoint, and I have no problem sharing it with anyone. So just ask her for it. Yeah.
You can take it?
Yes, you can take it. Yeah. Good. Thanks very much. Bye.